Today I'll be talking about the FLT3T, which is a tyrosine kinase, on the mutation for F691L for the potential drug targets to develop kinase inhibitors using the drug inhibitor gilteritinib and using the virtual screening throughout the process. So basically, the project context in this case, basically FLT3 is a tyrosine kinase that plays an important role in developing leukemia. Leukemia is a type of cancer that affects the blood and bone marrow. There's a rapid production of abnormal white blood cells, and it disrupts the body's ability to fight, basically. And then when there's a mutation in FLT3, it can overproduce FLT3 proteins and make a lot of leukemia cells. So basically, F691L mutation, it can cause this type of leukemia, but it can be targeted for different therapies. And for inhibitor drugs, they can block activity of proteins involved in cancer cell survival. So basically, the project description, typically using a drug discovery type of method, it takes a lot of time, like it was mentioned before, and it costs a lot of money. So basically, using the computational tools speeds up the process and understands the basis of the disease through the use of 3D structure of the target. So basically, the point of the study is to go more in depth of how the active site of FLT3 and its mutation using database searching, the protein structural properties, protein modeling, docking, and then using the structural-based virtual screening. And then it's basically to identify FLT3 inhibitors to test against the leukemia cells, and it's also to identify potential to binding the F691L mutation and block the FLT3 activity, basically. And with this inhibitor drug, it basically blocks the FLT3 protein activity that's mutated. And then going on to the research method, basically, we are looking at the computational screening of FLT3, which had to be screened against the wild type screen, which had the PDV of 6JQR. Basically, what was found was that the inhibitor drug gilteritinib had a docking score of -8.3 kcal per mole on the wild type, which showed its strong ability on the binding of the protein. But then it was less effective in the mutant version of this, which was -8.35 kcal per mole. And then the methods that were mentioned in the previous slide of modeling of the protein, docking, and the virtual screening were all used as part of the method, as it also shows in the workflow image right here. We basically do the ligand preparation and optimizing the structure, and then finding the ligand interaction, and from there on, we use the docking method and then compare the docking on the wild type and the mutant type, pick 10 to 20 compounds from there, and analyze their delta G scores and their ligand interactions with each other. And then this image just shows the 6JQR with the drug compound in here. And then continuing on, after the filtering process and the virtual screening, a sync-related drug and four other FDA drugs had the stronger binding ability to bind to the mutant, which basically were potential inhibitors due to the immune group and how it made the structure more stable. Basically, here's the 6JQR ligand docking with the wild type, and here's the mutant type, basically. And then the innovative aspect of this was completing a kinase assay after doing the virtual screening and the ligand docking. All of this process was very new and innovative that came up in recent years. And even though for the kinase assay, we didn't use myosin protein inhibitor, but it helped in designing an assay like this one, but using myosin protein and inhibitor, basically. And then this table shows the docking scores for wild type and mutant type for the first 5 drugs for sync-related drugs. And then the other 5 are the FDA approved drugs. And right here at the bottom, we have the gilteritinib drug inhibitor with the delta G scores on this side. And then for the research plan would be to basically do a kinase assay similar to what we did before, but comparing the gilteritinib drug and the FDA 1263 drug, since that was the FDA approved drug that had the strongest binding ability to the FLT3 activity and how it blocks that type of activity. And we would use the kinase GlowMax to identify the FLT3 kinase inhibitor and measure the kinase activity to create that luminescent signal. And we would also use the inhibitor buffer since it protects the FLT3 from breaking the peptide bonds that it has during the reaction. And then after finding the 3 main concentrations and the wild type immune type for FLT3 IC50 literature values, what would be expected as the results would be like the gilteritinib inhibitor drug would be less effective in the mutated kinase assay since the docking score increased in this case and the IC50 would be higher. And then for the FDA 1263 drug, it would end up having a higher IC50 score for the mutant kinase assay, but it will be less higher than the other drug due to having the docking score less increased than the other original inhibitor drug. And then also further analysis on the IC50 and virtual screening on just the FDA 1263 and gilteritinib inhibitor drug could also be done in order to see which drug is more potent and which one could block more FLT3 activity. And that's all. Any questions?
Why do you plan on using gilteritinib and FDA 1263, right? As the 2 inhibitors.
I plan on using them for like the kinase assays. In order to compare like IC50 values, like doing a separate kinase assay on gilteritinib and FDA 1263, and doing like 2 separate kinase assays and comparing their IC50 values in order to like see which drug could potentially have more of a binding affinity towards FLT3 blocking activity.
So you said there were 2 main top compounds that had this high binding affinity or ability from the 10, but were there any more like that?
Yes, on the table shown right here, these 4 circled right here, the FDA drugs, they proved to have like more binding affinity towards that kind of activity as well. And as well as zinc, this type of drug, zinc related, that also had like that strong binding affinity. Any other questions?
Okay, go to your title. So for your title, what's the title? Okay, so you want to emphasize, besides using the virtual screening, and also use the kinase inhibition assay. It's an experiment to be believing more critical for the drug discovery. So you want to understand that one, you also use the kinase inhibition assay. That's it.
Okay.
Okay, good.